All right, guys, on the previous screen, you saw that the more and the more you start compounding, the less and the less impact it has. So in the beginning, it seemed like it was having an impact, right? Look at this table here. If I take this situation, this is a formula that demonstrates what happens if we continuously compound, okay? So if n gets bigger and bigger, so if we start out with n as 1, then this answer is just 2. But then you can see if I make n equal to 5, I'm splitting the 1 into 5 pieces, but then I'm raising it for the 5th power. All right, and so you can see the number getting bigger and bigger and bigger as we go. So, but we get to a point where it just stops getting bigger. Why is it stopping getting bigger? So what we see here is it's like sort of counterbalancing itself out. I'm taking 1 and I'm dividing it by such a big number that this is tiny, but then I'm raising it to a really huge exponent, which is big. So the tiny and the big, to an extent, they don't necessarily cancel each other out, but they offset each other to the point where it's just minimal differences now. Okay, so you get to a point where it just converges to this number, 2.718, and that is a special important number. All right, so in the next slide, okay, this number actually is called the letter E. It's a lowercase e, it's always italicized like that, and it's called E in honor of this guy named Leonhard Euler. It's pronounced Euler, even though it looks like it should be Euler. It's Euler, and he's a very famous mathematician. He's done all kinds of stuff, especially geometry related. But he's the one that discovered this property of this letter E. So when we have scenarios where we are doing continuous compounding, we're going to use E, right? And we're going to, instead of using the compound interest formula that we had been using, we're going to use this formula in its place, right? So if you were doing a problem that's about interest on a credit card or on a loan and it tells you it's compounding quarterly, monthly, yearly, whatever, go ahead and use the compound interest formula. But if it's telling you that it's just compounding continuously, we're going to use this one instead, right? And we're going to take the next few minutes to demonstrate how that's used because I know it's brand spanking new and it can be a little overwhelming. Okay, so, but it's actually not too bad. Trust me, I've taught this many years and it's not too bad. Let's look at this example. If we wanted to compare $100 and it's being earning 7% compounded weekly, that's not continuous, but it's pretty frequent compounding, right? Weekly. Let's see how much this $100 would be after a whole year. So there's the old way of doing it, right? 0.07% weekly, 52 weeks a year. In the 52 weeks, we're going to have $107, 24.579696 All right, if we were going to use the same thing, but base E, we still start out with $100 as our P, and then E, and then our R is 0.07, and T is our time in years, so we're just going to say that's 1. And look, it's very, very close, right? So compounding 52 times a year is ridiculously close to compounding continuously. Right, you need to get used to this, so we're going to look through 2 more examples with you guys. We're going to do one where we're doing exponential growth, and where we're going to do an exponential decrease. So let's look at this example. The population of the United States, I just asked Alexa, she told me it's 326 million. All right, it's growing at just under 1% a year. That's why I just rounded it to 1%, okay? All right, the old way we would have calculated this, just like earlier this week even, we'd say, okay, well, 326, and it's growing by 1%, so we would do 1 plus the rate of 0.01, so 1.01 to the t power. And that would give us our new formula to calculate population. Just plug in t number of years and go. All right, the new way, you're starting out with 326. You use your base E and then use 0.01. No 1.01, just 0.01. It's E to the RT. Okay, I'm going to do a calculation for you really quickly. let's look if I do e. See, look, the calculator even knows what e is. 2.7182818. Okay. E to the 0.01 power. You see what e to the 0.01 power is? It's 1.01. Just slightly bigger, because the slightly bigger part means it's compounding continuously. So the old way, no compounding, and then the new way, it's like continuously compounding. It's more realistic to do continuously compounding, because that's how populations grow. It's continually growing, right? It's not like, oh, once a year the population changes. The population is constantly growing. So this is actually a very more realistic way to write this. So we could use this. You just plug in t for the number of years and calculate the population. All right, let's look at how we could do this with exponential decay. Right, let's look. A patient took 250 milligrams of an antibiotic, and it's being absorbed into their bloodstream at a rate of 10% an hour. So we want to create a function for this. So the old way, we'd say, okay, start out with 250, and remember we would multiply it by 0.90 or 0.9, because 10% is going away, 90% of it remains. And this would tell me how much is remaining in their bloodstream after t, and in this case t is hours. If we want to do it the new way, this is actually probably a little bit more straightforward. Still starting out with 250, and we have e here, and since it's decaying at 10%, we just say it's negative 0.10. That negative rate tells me it's decaying. Really quickly, let's look. What's e? E to the negative 0.10 power. Oh my gosh, it's so similar. Look, it's the exact same thing as 0.90, right? So it's slightly bigger than that because it's continuously compounding, so we know it's actually going to decrease a little bit more quickly. So again, the way the medicine's absorbed into your system, it's continuously being absorbed into your system. It's not just, oh, every hour 10% goes away. It's constantly changing. So using base E is a more realistic approach. This model is more likely to be used by scientists and mathematicians. I know this is new. I know, don't panic. We're going to do a lot of practice. Next week we will continue to practice with base E. And you'll learn how to, oh my gosh, how would I solve for t? At this point, you don't even know how you would solve for t. So that'll be what we'll be getting into next week.